Hello guys, on this video I'm going to talk about mathematics and the unit circle. So this is very interesting for you to understand how to get values of cosine, sine, tangent and cotangent from this unit circle. So I'm going to draw the unit circle, and we will have a circle more or less with a radius of 1. Here 1, 1, minus 1, minus 1. And before I go on, important thing that we should understand on the unit circle is that it is divided by 4 sections of 4 quadrants. Here is the first quadrant for positive values of x and y, and between 0 degrees and 90 degrees. The second quadrant will be here with negative values of 0 and positive values of y, and between 90 and 180 degrees. The third quadrant will be between 180 and 270 degrees, and for values of x and y both negative. Finally, the fourth quadrant will be between 270 and 360 degrees, which is the same of 0, and for values of x greater than 0, so positive values, and y negative. So this is the 4 quadrants of the unit circle. I'm going to make some reference of them during this video, so it's good for you to have this idea here. So now, regarding the sine and cosine functions, there's something very interesting. For the cosine, we can get measurements of the cosine in the horizontal axis. So here I can get the values for cosine, and for sine I will get the values in the vertical axis. So if I have angle here of alpha degrees, this means that I can get the cosine here, making this measurement here. It will give me the value of cosine alpha, and remember this is true just in the unit circle. And if I make the projection of my angle here in the vertical axis, I will get the value of sine of alpha. This measurement here will be the sine of alpha. Now let's see how my values of sine and cosine will vary around the unit circle. Remember that it's counterclock, so we move our angle in counterclock direction. And let's create a table here. We have 0 degrees, 90, 180 and 270. Remember that 360 is the same of 0, so going to put 360 here above 0. And we will have the following values. So for sine, we start with sine. For 0 degrees, if we have our angle here in 0 degrees, we will see that there is no projection of this angle in the vertical axis, but just a single point. So this means that the sine of 0 degrees will be 0. But the cosine will have all these measurements here which is 1. It is maximum amplitude, it's 1. Now if I start moving my angle towards the 90 degrees, what we will see is that the sine projection will start to increase and the cosine will decrease. So when we reach 90 degrees, we will have that the sine projection will be all these measurements here, which will be 1, and the cosine will be just this single point here in 0, which is 0. Now if we move our angle to the second quadrant, well, we can still get the sine values with this projection here and the cosine with the projection in the horizontal axis. And what we will see that as we move our angle towards 180 degrees, the sine will be decreasing and the cosine projection will decrease from 0 to -1. So when we reach 180 degrees, we will have that the sine will be 0 again and the cosine will be -1, the minimum amplitude. Now for the third quadrant, what we will see is that while we move our angle towards to 270 degrees, we will have the projection of the cosine increasing from -1 to 0 and the projection of the sine decreasing towards -1. So when we reach 270 degrees, we will have that the sine of 270 degrees will be -1, the minimum amplitude of the sine function, and the cosine will reach 0 again. Now in the fourth quadrant, what we will see is that the sine projection will move back to 0 and the cosine will increase again towards 1. So we will reach the same situation that we have in 0 degrees, where the sine will be 0 and the cosine will be again 1. So now for the functions of tangent and cotangent, I'm going to draw the circle again, and it's very easy as well. For tangent, we will have a line that will be parallel to the axis of the ellipses, the vertical axis, and if I have here my alpha angle, I can determine the tangent by moving these points here and see where it reaches the tangent line. So this measured here will give you the value for tangent of alpha. Now if you take a careful look here, we will see that when we have 0 degrees, the line here will be 0, so tangent of 0 is 0. But as we move towards to 90 degrees, we find that tangent will increase towards infinite, and when we reach 90 degrees, the angle will be parallel with the tangent line. So you cannot determine the value of tangent of 90 degrees because it will go to infinite. I'm just drawing here the infinite symbol, but you cannot say that it's infinite, you just say that it's indeterminate. So you cannot determine the value for 90 degrees. Now, if you move our angle in negative direction, we have here minus 90, which is the same of 270, depending if you go in the normal direction or if you go in the opposite direction. So you have here also minus 90 degrees. And things will be very similar. You know, when you have the angle moving towards minus 90, the value of the tangent will go down, down, down and down towards minus infinite, and when you reach the minus 90 degrees, you will get minus infinite. Well, in fact, it's not determined. You cannot determine the value for minus 90. Now, for the second and third quadrants, you have a situation. If we just try to make these calculations, you'll find that you cannot have a value for the second and third quadrant. But however, you can make an operation of get the angle alpha with more or less 100 degrees, so you can position your angle in the first or fourth quadrant, and then you can make a reading in the tangent line. Now, for the cotangent, it will be a line parallel with the horizontal axis, and to get the value of the cotangent is very easy. You just keep moving your line, your angle, until you reach this measurement here, and this will give you the value for cotangent of alpha. So for cotangent, you see that for 0 degrees you will have a similar situation than when we had the tangent of 90, because it will be parallel to the cotangent line, which means by definition it only will meet the cotangent line in the infinite. So you cannot determine the value for cotangent of 0. Now, as you move our angle towards 90 degrees, the value of cotangent will decrease until you reach 0. So cotangent of 90 will be similar of the tangent of 0, which will be 0. Now, if you move to the second quadrant, this angle here will move towards minus infinite. So when you reach the 180 degrees, you will find that you cannot determine the cotangent, because its limit will be minus infinite. Regarding the third and fourth quadrants, you have a similar situation for the second and third quadrants for the tangent. You cannot you cannot determine the cotangent directly unless you make an operation of the angle more or less 180 degrees, so you can reach the first or second quadrant. So directly there is no way to get the values of, for instance, 270 degrees. Okay, so now I'm going to talk about 3 other angles. They are very common angles. They appear many times in many exercises. That in some guys also call them notable angles. So I'm going to focus only now on the first quadrant. and let's talk about these three angles. So this is not very accurate, but well. So the first one will be the angle of 30 degrees. The other one will be (45 degrees). Finally, the other angle will be 60 degrees. So we have here three nice angles of 30, 45 and 60 degrees. Now, values for our trigonometric functions. So we'll have here 30, 45, 60. If you prefer the cities in radians, okay, you have P over 6, P over 4 and P over 3. And let's build the table. Sine and cosine. Okay, so for the sine function, well, when you have an angle of 30 degrees, the projection here in the vertical axis will be in the half position of this unitary circle. So this means that you will have 1/2. So sine of 30 degrees will be 1/2. Now for 45 degrees you have another value that will be square root of 2 over 2. So the sine for 45 degrees will be square root of 2 over 2. And finally, for the 60 degrees, you will have another number that will be square root of 3 over 2. These are known measurements and known values for these three angles here. Now for cosine. For cosine, if you look at, for instance, this angle of 30 degrees, and if you try to find the angle between the vertical axis and this angle here, it will give 19 minus 30, which will be 60 degrees. So you can easily say that the cosine of 30 degrees will be the same value of the sine of 60 degrees, and this will be square root of 3 over 2. For 45 degrees, this will be the same value of the sine. So cosine of 45 will be square root of 2 over 2. For 60 degrees, we will find that 90 minus 60 will be 30 degrees. So the value of the cosine of 60 degrees will be the same value of the sine of 30. So it will be 1/2. Easy. Now regarding tangents and cotangents. So we will have here the tangent line. I'm not going to draw the rest, it's just for the first quadrant, and the cotangent. Cotangent. And now let's see, there is an angle that is, well, very easy to understand is 45 degrees, because if you have here a square, you will have that the angle of 45 will meet both lines of tangent and cotangent on 1. So the tangent of 45 degrees will be 1, and the cotangent will be 1 as well. Well, and by definition, we know that tangent of alpha is sine alpha over cosine alpha. And for 45 degrees, both sine and cosine have the same value. So it's easy to understand then that square root of 2 over 2 dividing by square root of 2 over 2 is 1, of course. And we also know that cotangent will be the inverse of the tangent, or cosine alpha over sine of alpha. In this case it will be 1 as well. Now, for 30 degrees, we'll find that this value here will be given by square root of 3 over 3. So the tangent of 30 will be square root of 3 over 3. And for 60 degrees, it will be square root of 3. Now, you can, if you don't want to memorize all these values, and if you just want to focus in values of sine and cosine, that will be enough. You can get these values of tangents by using this expression here. In fact, for 30 degrees, you will have the sine of 30, that is 1/2, dividing by the cosine, which is square root of 3 over 2, and this will give you 2 over 2 times square root of 3. So you can say, hey, but this result is 1 over square root of 3. It's not the same of square root of 3, isn't it? Let's see. So if you have 1 over square root of 3, and if you multiply both parts of the fraction by square root of 3, you will have square root of 3 over square root of 3 times square root of 3, and this is square root of 3 over 3. So you can get this value here as well. For 60 degrees, we'll have tangent of 60 degrees equals 2 sine of 60, which is square root of 3 over 2, dividing by the cosine, which is 1/2. So this will be 2 square root of 3 over 2, which is square root of 3. So you can get these values easily from this expression here. Now, cotangent. Cotangent, we will see that, and because it's the inverse of tangent, we find that the cotangent for 30 degrees will be square root of 3, and for 60 degrees will be square root of 3 over 3. In fact, using cosine and sine as well, you will have that cotangent of 30 degrees should be cosine of 30 degrees square root of 3 over 2, dividing by sine, which is 1/2. And again we will have 2 square root of 3 over 2, which is square root of 3. So cotangent of 30 degrees is square root of 3. Same value for the tangent of 60. Now for 60 degrees, you will have that the cotangent of 60 degrees will be given by cosine of 60, 1/2, over the sine of 60, which is square root of 3 over 2. This will give you 2 over 2 times square root of 3, which is 1 over square root of 3, and using the same calculations we used here for the tangent of 30 degrees, and multiplying both parts of the fraction by square root of 3, we will have square root of 3 over 3. Easy enough. So now, for the other quadrants, what we will see is that the values, you will have the same projections, will be always around these values here, but you also have to be careful with the signs. For instance, the cosine in the second quadrant will be negative. So for instance, the cosine, if you have here a 30 degrees angle from the vertical axis, this will be then 120 degrees. The cosine will be minus 1/2, and things like that. So you have to be careful with the signs, but every values you will get will be always around these values here. So it's very easy, and I hope that this video was useful for you, and I hope that you liked this video as well. So if you like it, feel free to subscribe my channel, and also you can visit my website www.cmmps.me to know about more information about me. There you can also request a video if you want to see any subject in a video. So thank you very much, and see you next time.